Okay, so first, before actually starting into today's class, we'll revise once again the definition. Those who are those who are still new to this chapter. Okay, so what is the continuous function? Continuity is defined at two ways. One is at a point and in the entire domain. So how to verify it is continuous at a point? If x is equal to c is the point where you have to verify. First, you have to see whether f of c exists. Andre kotta function. Suppose your function is f of x is some function they have given. Okay, in place of x, you have to put x is equal to c, and you have to check whether it is a finite value or not. If it is a finite value, then f of c exists. Okay, if it is an infinite value, f of c does not exist. Okay, second condition is you have to find whether limit exists. That is, limit is finite, limit is well defined or not. And the third condition, you have to check whether both the answers are same. Whatever answer if, you get when you put f of c and limit, when you find the limit, if both the answers are equal, then we say that the function is continuous at x is equal to c. Okay, if it fails any of these three conditions, okay, which means if it fails first condition, or if it fails second condition, or if it fails third condition, then we say that the function is discontinuous at x is equal to c. Okay, this is about point. So point you have to go for this definition. Now suppose if they give you a function and you have to check whether this function is continuous or not. So what you will do? First you will take a random element c. Okay, you will take a random element c, and at the c you have to check whether it is continuous or not. Okay, so if it is continuous at a c, then we generalize it as the function is continuous in the entire domain. Okay, ಒಂದು ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಕಂಟಿನ್ಯೂಸ್ ಆಗ್ತಾ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ randomly you have to pick a point. If at that point the function is continuous, then the function is continuous at each and every point of its domain. So this is how we solve the problems. So we had solved all these questions in the previous two classes. Okay, so this was the last question which was discussed. Today we'll move on to the next question. So what you have to find, you have to check the continuity of this function, where f of x is given by, how the function is given, f of x is given by, f of x is equal to 1 by x minus 5, and they have clearly told that x cannot be equal to 5. Okay, they have told us that x cannot be equal to 5. Why x cannot be equal to 5, students? What happens to the function if x is equal to 5? Just substitute the value of x as 5 in the function and check what happens if we put x is equal to 5. Can anyone tell me why we cannot put x is equal to 5 here? Why we cannot put x is equal to 5 over here? Just put x is equal to 5 in the question. So what is the question? F of x is equal to 1 by x minus 5. Put x is equal to 5. So that is f of 5 if you find, what you'll get? 5 minus 5. So that is 1 by 0. So what is 1 by 0? What is 1 by 0, students? What is 1 by 0? Zero is error, correct. So 1 by 0 is undefined, or you won't get the value, correct? Okay, so 1 by 0 is an undefined value, or 1 by 0 is not 0. 1 by 0 is not 0. If you have a calculator, you just check, you'll get it as mathematical error, which means 1 by 0 is not defined. Okay, that's why the function is not continuous at x is equal to 5, because first condition, you know, what is the first condition which you have to verify at a point? Okay, what is the first condition? F of c exists or not, correct? So if you put c is equal to 5, okay, if you put c is equal to 5, second condition is limit f of x as x tends to c exists or not, and third condition you have to check whether both are equal or not. Okay, so if you put x is equal to 5, or if you take c is equal to 5, what happens? The first condition itself is failed because it is an undefined value, which means f of c does not exist if c is equal to 5. So clearly the function is not continuous at x is equal to 5. Okay, if case 1 is what you have to take, if you take x is equal, c is equal to 5, we get f of c is equal to 1 by 0, which is not defined. Therefore, by the definition of a continuity at a point, even the first condition itself is failed. So the function is not continuous at x is equal to 5. Okay, now you take case 2. Okay, case 2. What is case 2? You have to take x, you have to take c value, x is equal to c, which is not equal to 5. Okay, you have to take a value c which is not equal to 5, which means it can be either greater than 5 or it can be less than 5. Okay, so your c is either, it can be anything, either it can be greater than 5 or less than 5. Okay, so then you have to verify the 3 conditions. So you don't have to verify separately. Greater than 5 ಆದಾಗ ಏನಾಗುತ್ತೆ, less than 5 ಆದಾಗ ಏನಾಗುತ್ತೆ ಅಂತ verify ಮಾಡಬೇಕಾಗಿಲ್ಲ, because the function is same in the entire domain. It is 1 by x minus 5. Okay, so what you can do, at c is equal to 5, the function is not continuous. Check at c not equal to 5. Okay, at c not equal to 5. So what happens? The first condition is f of c. What is f of c? 1 by c minus 5. Clearly 1 by c minus 5 is well defined. Why? Clearly 1 by c minus 5 is well defined. Why, students? 1 by c minus 5 is well defined. Why? Can anyone tell me why it is well defined? Why it is well defined? 1 by c minus 5. What is the value of c? C is not equal to 5, correct? Yes, it exists. Yake? Why? Because ಇಲ್ಲಿ c ಏನು ತಗೊಂಡಿದ್ದೀವಿ, it is not equal to 5 ಅಂತ ತಗೊಂಡಿದ್ದೀವಿ, correct? We have taken c is not equal to 5. So c can be any value greater than 5 or less than 5. ನಮಗೇನು ಗೊತ್ತಿದೆ, function ಇಲ್ಲಿ define ಆಗ್ತಿಲ್ಲ if it is x is equal to 5. Only then the function is not defined. All the other places function is defined. So we have taken c not equal to 5, which means clearly f of c exists. Okay, clearly f of c exists. Now, what is the second condition? Limit of f of x as x tends to c. So that is limit of, what is f of x? Here c is not equal to 5. So f of x is 1 by x minus 5 as x tends to c. Substitute the value of c in the place of x. So c minus 5 you will get. Correct? Even this exists. Okay, even this function exists. Okay, because we had proved 1 by x exists, correct? We had proved that 1 by x is continuous. So this limit also clearly exists. Okay, so you can see that the first limit and second limit is existing, which means the first and second condition is verified. Okay, and what about the third condition? It should be equal. So you can see that the value of f of c is 1 by c minus 5. The value of limit of f of x as x tends to c is also 1 by c minus 5, which means both are equal. Therefore, the function is continuous. The function is continuous. Okay, function is continuous for x not equal to 5. Okay, so the function is not continuous if x is equal to 5, and function is continuous if x is equal to 5. So is this clear, students? Whether this is clear? Whether this is clear? Yes. Okay, so we'll move on. Okay, fine. So this is your next question. F of x is equal to x square minus 25 divided by x plus 5. Okay, so this is your next question. F of x is equal to x square plus minus 25, x square minus 25 divided by x plus 5. Okay. Okay, there is a mistake, student. This is x not equal to minus 5. Okay, here also they have told us that the function cannot take the value x equal to minus 5. Why x cannot take the value minus 5? Why x cannot take the value minus 5 in this function? Why x cannot take the value -5 in the function? What happens if we take x is equal to -5? What happens? Just check, student. Substitute x is equal to -5 in the function. What you'll get? Substitute x is equal to -5 in the function. What you'll get? Check what you'll get. Okay, so you'll get something +5 and -5. Yeah, that we can do. But first you check if you put x is equal to -5, what you'll get. Okay, so what you are getting? F of x is equal to -5 square minus 25 divided by -5 plus 5. Okay, so that is 25 minus 25 divided by 0. 0 by 0, whether it is a well-defined form, 0 by 0 is a well-defined form. Is it a well-defined form? 0 by 0. 0 by 0 is a well-defined form, or it is not defined? Just check with your calculator what you'll get if you put 0 by 0. Okay, fine. Okay, so it is not defined. So clearly what you can say clearly, if the function is not continuous if x is equal to -5. Okay, clearly you can say that because the first condition itself is failed. If you put x is equal to -5, you're getting a not defined form, which means the function is not continuous if x is equal to -5. Okay, so now before you continue, as Niti Lakshmi told, we can split the factors. Okay, so that is f of x is equal to x square minus 25 divided by x plus 5. So can I write this as x square minus 5 square 25? I can write it as x square 5 square, correct? So it is x square minus 5 square divided by x plus 5. So what you can observe over here in the numerator, what you can observe in the numerator, what you can observe, students? What you can observe in the numerator? Numerator, it is x square minus 5 square. Do you remember any identity which you had studied in your high school? X square minus 5 square. Do you remember any identity? What is that identity? Which formula? Yeah, you remember a formula. Which formula? A square minus b square. Good, Nur Fatima. It is a square minus b square. So what is a square minus b square? It is a plus b into a minus b. Good, Simran. Good, Dikshita. It is a plus b into a minus b. So what happens there? It happens x plus, what it get converted to x plus 5 into x minus 5. Good, Madiha. So you substitute it. So what you'll get? It is equal to x plus 5 into x minus 5 divided by x plus 5. So we have used a square minus b square is equal to a plus b into a minus b formula. Okay, so now what happens? X plus 5 get cancels. So your function is reduced into a simpler form called x minus 5. Okay, the function is reduced into a simpler form. F of x is equal to x minus 5. Okay, so now for this function, you have to verify whether this is continuous and in the entire domain except at -5. Okay, you have to check whether this function is continuous in the entire domain except at -5, because at -5 already we had discussed the function is not defined. So except this value, you have to check whether it is continuous at all the other real numbers. So what you have to do, you have to take a random real number. Let C be any real, or you can say let C belongs to R minus 5, which means you are including, C can be any real number, but it cannot be equal to -5. R minus -5 means C can be any real number, but it cannot be minus 5. So you verify the three conditions. That is f of C exists, limit f of x as x tends to C exists, and whether both are equal. Can anyone tell me what whether it is continuous or not at C? Can anyone tell me whether it is continuous or not at C? Whether it is continuous or not at x is equal to C, it is continuous. Good student. So you have verified. So those who are still, yes, it is continuous. Why? Because what you'll get, f of C is equal to C minus 5, correct? C minus 5. C is a real number which is not minus 5. So it is well defined. Yes, it exists. Then you have to check for the limit. Limit f of x tends to C is equal to limit x minus 5 as x tends to C. Clearly this exists because this is a polynomial function, correct? So that is C minus 5 also exists and both are equal. Therefore the function is continuous at x is equal to C, where C belongs to, C can be any real number except minus 5. So if it is continuous at C, it is continuous everywhere except at x equal to minus 5. So the given function is continuous everywhere, but it is not continuous at x is equal to minus 5. Hope this is clear, students. Okay, so we'll continue. Yeah, next question. Okay, so who will give me the definition for this function? F of x is equal to mod x minus 5. There is something called mod. You know the definition of mod. So how the function will be defined? How can we define the function? How can we define the function? Can anyone tell me the answer? There is mod. So it is not simple as it is simple, but you should just split it out. Okay. So how to do this? How to go about this? So what generally if you have f of x is equal to mod x, what you'll write the definition is x if x is greater than or equal to 0, correct? It is minus x if x is less than 0, correct? If x is less than 0. Why we write the why we split the definition into two parts? Because if you take x greater than 0, which means x is a positive value. If you put a positive value, you'll get answer to be positive. What is the main use of mod function? Whatever the negative thing you give, it turns it out to be positive. Okay, so if you put x greater than 0, okay, if you put x greater than 0, here x becomes x is already positive. So whatever the value you give, the same value you will get. If it is x is less than 0, which means it is a negative value, correct? If x is less than 0, which means if you take x is equal to minus 1. Okay, if you take x is equal to minus 1, the function f of x is defined as, how it is defined? It is defined as, since x is less than 0, the function is defined as minus x. Why? Minus we have, what is our x? X is minus 1. So it becomes minus into minus plus. So it becomes a positive value. Okay, that's why we have defined f of x is equal to minus x if x is less than 0. Because x less than 0 implies the value is a negative. Negative into negative, if you do, only then you'll get a positive value. Okay, similarly, you have to define the function over here. So can anyone tell me how we can define the function? How can we define the function? Okay, so I'll write the function. You just give me the values. Okay, so f of x is equal to mod x minus 5. Okay, I'll define it as, x minus 5 and minus of x minus 5. Okay, I'll define the mod function as x minus 5 and minus of x minus 5. When this value it takes, if x is, I should get it as a positive value. Okay, on particular x in Nantra, if I substitute that value to x minus 5, okay, if I take some value to x and if I put x minus 5, I should get a positive value. So what is that minimum value so that it becomes positive? So x should be, what should be the value of x? What should be the value of x students? What should be the value of x? What should be the value of x? What should be the value of x? Okay, at what value f of x becomes 0, students? At what value f of x becomes 0? I should get the answer is equal to 0. At what value f of x becomes 0? At what value f of x becomes 0? Yes, if I put x is equal to 5, correct? If I put x is equal to 5, 5 minus 5 becomes 0. Okay, so if I take a value greater than 5, what it becomes? Whether it is a positive value or a negative value. If I take a value greater than 0 in this function, okay, if I take a inside, only consider the function inside the modulus. Modulus ಒಳಗಿರುವ value ಏನಾಗುತ್ತೆ ಅಂತ ಹೇಳಿ. If I take x greater than 5, x greater than 5 ತಗೊಂಡ್ರೆ, okay, if I take x greater than 5, what happens to the thing inside the modulus? Modulus ಒಳಗಿರುವುದು ಏನಾಗುತ್ತೆ? Whether it will be a positive or negative. So what happens? It becomes positive. Okay, so if x is greater than 5, then the value inside the modulus function becomes positive. Okay, if it is less than 5, if it is less than 5 students, if it is less than 5, it becomes negative. So at 5, it becomes 0. If it is less than 5, it becomes negative. If it is greater than 5, it becomes positive. Correct? Did you understand this? At x is equal to 5, the function becomes 0. Okay? And if it is greater than 5, the thing inside the bracket becomes positive. If it is less than 5, it becomes negative. So what should be the first limiting? If x should be, this should be a positive value. When it will be positive? When it will be positive? If x is greater than or equal to 5. Good. So f of x is x minus 5. So what is the ultimate aim of mod function? We should get a positive value. Positive value yavaga sigutte? Greater than 5 iddaga sigta untu. Correct? So x minus 5 positive aguantaddu if it is greater than 5. Okay, and it is negative if x is less than 5. Okay, it is it is positive if x is greater than 5. It is negative if x is less than 5. When it is negative, we have to define the function in this way. When it is positive, we have to define the function in this way. Okay, did you understand? But there is a case called equal to 5. So where should I include? In the first or in the second? Equal to 5. Where should I include? In the first part of the definition or in the second? Equal to 5. First, correct? Because 0 is also positive, we can consider. So if x is greater than or equal to 5, okay, if x is greater than or equal to 5, the given function is defined as x minus 5. Okay, if x is less than 5, the function is defined as minus of x minus 5. Did you understand why we have taken in this form? Did you understand why we have taken it in this form? Should I repeat? Okay, fine. You have understood. Okay. Okay, fine. So now we'll go to, okay, I should repeat. Okay. Okay, fine. So modulus function, what it makes, it makes everything to be positive, correct? So normal ಆಗಿ ನಾವು ಹೇಗೆ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ? x if x is greater than or equal to 0 minus x if x is less than 0. ಯಾಕೆ ಹಾಗೆ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ ಅಂತ ಹೇಳಿದ್ರೆ ಈ ಫಂಕ್ಷನ್ ಯಾವಾಗ 0 ಆಗುತ್ತೆ if I put x is equal to 0, correct? If I put x is equal to 0 then it becomes 0. So 0 ಗಿಂತ ಜಾಸ್ತಿ ಇರೋ ವ್ಯಾಲ್ಯೂ ತಗೊಂಡ್ರೆ ಒಳಗಿರೋ quantity ಏನು, it will always be positive. Okay, suppose x less than 0 ತಗೊಂಡ್ರೆ ಒಳಗಿರುವ ಕ್ವಾಂಟಿಟಿ ಏನಾಗ್ತಾ ಇದೆ, ನೆಗೆಟಿವ್ ಆಗ್ತಾ ಇದೆ. ಅಂದ್ರೆ 0ದು ಅಕ್ಕಪಕ್ಕ the value change ಆಗ್ತಾ ಇದೆ, ಕರೆಕ್ಟಾ? if the value of x is less than 0 it becomes negative, the value of x is greater than 0 it becomes positive. So which means 0 is the deciding factor. Okay, 0 is the deciding factor. Similarly, if you take this function, ಈಗ function ಏನಾಯ್ತು, inside the modulus it is x minus 5. Okay, when it becomes 0 if x is equal to 5. Okay, and if x is greater than 5 it becomes positive, and if x is less than 5 it becomes negative. Okay, so ಇಲ್ಲಿ ಏನಾಯ್ತು, if it is negative ಅಂತ ಹೇಳಿದ್ರೆ ಅಲ್ಲಿ ಒಂದು ಮೈನಸ್ ಅನ್ನು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಬೇಕು, ಯಾಕಂದ್ರೆ ನೆಗೆಟಿವ್ ಇಂಟು ನೆಗೆಟಿವ್ ಬಿಕಮ್ಸ್ ಪಾಸಿಟಿವ್. ಸೊ ನೆಗೆಟಿವ್ ಬರುವಲ್ಲಿ ಏನ್ ಮಾಡಬೇಕು, ಮೈನಸ್ ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಬೇಕು. ಪಾಸಿಟಿವ್ ಇರೋದನ್ನು you have to write as it is. Okay, that's why we have defined the function in this form. Okay. Okay, so now we'll check whether this function is continuous or not. Okay, so we'll define the function again. So it is f of x is equal to x minus 5 if x is greater than or equal to 5 minus of x minus 5 if x is less than 5. Okay, so here you have to check the continuity. You have to go for 3 cases. Okay, you have to go for 3 cases. Can anyone tell me which are those 3 cases? Which are those 3 cases? Can anyone tell me which are those 3 cases? I'm not talking about the definition. I'm asking which are the 3 cases which you have to verify. You can see the definition is varying, correct? Definition vary ಆಗ್ತಾ ಇದೆ. Yeah, 3 conditions I understood. 3, I'm not talking about conditions. Yeah, I'm not talking about conditions. Nitilakshmi, just modify your answer. You're near to it. Just modify your answer. Greater than 0. Noor Fatima, just check if it is greater, because we are defining the function x greater than 5, x less than 5, and x is equal to 5. So what are the 3 cases? So what are the 3 cases? Students, I'm not talking about the definition. I'm asking the cases which you have to discuss over here. Okay, so which are the 3 cases? The first case is you have to check whether the function is continuous at c is equal to 5. Okay, you have to check whether the function is continuous at c greater than 5, okay, c less than 5, and at c is equal to 5. So these are the 3 cases which you have to verify. Andre, if you take value greater than 5, any value, any real number greater than 5, you have to check whether the function is continuous. If you take any value less than 5, you have to check whether the function is continuous. And what happens at x is equal to or c is equal to 5. So these are the 3 cases which you have to verify. So what is the first case? Case 1 is let c greater than 5. Why we have taken these 3 cases? Because your function is varying near to 5. ಒಂದು 5 ಅಲ್ಲಿ change ಆಗ್ತಾ ಇದೆ. Greater than 5 ಆದಾಗ ಒಂದು function ಆಗ್ತಾ ಇದೆ. Less than 5 ಆದಾಗ your function is different. So we are taking these 3 cases. C greater than 5, C less than 5, and C is equal to 5. Okay, so if it is greater than 5, you are taking any real number which is greater than 5. So what happens to f of c? So how we have to, whether we have to define it in the first form or the second form if c is greater than 5? First form or second form, students? First form. First form or second form? First form, because for all x greater than 5, f of x is x minus 5. So what happens to f of c? F of c is c minus 5, correct? F of c is c minus 5. Since c minus 5 is a real number, clearly it exists. Okay, so second thing, you have to check for the limit. Limit of f of x as x tends to c exists or not. That is limit of, if c is greater than 5, f of x is nothing but x minus 5, correct? If x is greater than 5, f of x is nothing but x minus 5. Substitute that definition of the function. So it is x minus 5 as x tends to c, which is c minus 5. So you can see clearly it also exists. So the function is continuous, both are equal, correct? So the function is continuous if c is greater than 5. Or the function is continuous if the value of x is greater than 5. Similarly, you check for value, if what happens with the value of, if c is less than 5. Okay, what happens if c is less than 5? Can anyone tell me what happens if c is less than 5, whether it is continuous or if what happens if c is less than 5, students? Okay, I'll explain again. Okay, it is continuous, it is not discontinuous. C less than 5 ಆದಾಗ ಏನಾಗುತ್ತೆ? f of c ಹೇಗೆ? C less than 5 ಇರಬೇಕಾದ್ರೆ f of c ಏನಾಗಬೇಕು? C less than 5. ಯಾವಾಗಲೂ x less than 5 ಇದ್ದಾಗ f of x is minus of x minus 5. Here already c is some value which is less than 5. Okay, c is some value which is less than 5, which means f of c is minus of c minus 5. Again it exists. Okay, again it exists. And check the limit of f of x as x tends to c. Okay, so what is the definition? If the value of the, if x is less than 5, how we'll define the function? In the first manner or in the second form? In the first form or in the second form? Second form. Okay, substitute it. Okay, substitute it. So I'll get it as minus of x minus 5 as x tends to c. So it is minus of c minus 5. Clearly this also exists. And you can see both are equal. So the function is continuous even if your value of x is less than 5. So the function is continuous if x is greater than 5 and function is continuous if x is less than 5. So go for the third case. Third case is what happens if x is equal to 5. Sorry, so the function is f of x is equal to x minus 5 if x is greater than or equal to 5, minus of x minus 5 if x is less than 5. So for c greater than 5 and c less than 5, the function is continuous. What happens at c is equal to 5? So at c is equal to 5, what is f of c? At x is equal to 5, f of x is x minus 5. So that is, you have to find what is f of 5. So it is x minus 5. 5 minus 5 is 0. 0 is a well-defined quantity. Now you check the left hand limit and right hand limit. Okay, take this as homework question because we have less than 1 minute. Take this as homework question. Check whether the function is continuous at x is equal to 5. Using this definition, you check whether the function is continuous at x is equal to 5. Left hand limit anta helidre 5 ಗಿಂತ ಕಡಿಮೆ ಇರಬೇಕಾದ್ರೆ f of x ಇದು value ಏನಾಗುತ್ತೆ? It is minus of x minus 5. And if it is greater than 5, that is right hand limit becomes x minus 5. Check whether both are equal. If it is equal, then the limit exists. And check whether the value of the limit is equal to f of 5. If it is true, you can say this is continuous. Okay, at x is equal to 5. Take this as homework question, students. Or we'll discuss in the next class. At 12 o'clock we'll discuss. Okay, you just try it out when you come for the next class. That is at 12 o'clock you have one more session. So you just try and get me the answer whether it is continuous or not at x is equal to 5. Okay.